First thing you want to do is open up and make a new model in Adams view. Then you're going to want to make sure that the Earth is set to normal, your gravity, as well as -y in the global. You're going to want to rename your project to projectile motion. Make sure the units are in millimeters, kilograms, newtons, seconds, degrees, and your working directory is what you would like it to be. The next thing you're going to do is from the setting tab up here, you are going to edit working grid. You want to make your X size 4,000 millimeters. And your Y size 3,000 millimeters. You want to keep the spacing at 50 and 50 and click apply and OK. The next thing you want to do is create your plane for the stone to fly on. So up here, rigid body box, you want to click on that. Where it says new part, put on ground. This is in centimeters, so we're going to have to convert it from our millimeters. The length of it will be 3,500 or 350 centimeters. The height is going to be 100, same as the depth, which is 10 centimeters. And you want to select all of these as well. Next, you can see that you have your square here. You want to right-click on your working grid, and this location event tab will pop up. You want it to be at the coordinates 0, -150, 0, just like it is here. Click apply, and it will put in your box for your plane. The next thing you want to do is go up here on bodies, ground, and rename this box. You can rename it to whatever you would like. So here we will name it ground plane. Select apply. Next you want to do is click on these rigid sphere right here. For the radius, you want it to be 50 millimeters or 50 millimeters, so 5 centimeters. You want to select on the new radius. We do not want to switch the new part here. Next, you want to right-click on the screen here again, so that way you can set your event location. And here you want it to be 0, 0, 0 at the origin. Next thing we want to do is go up to this part here and rename this as well. Oops. And this one we are going to call stone. Next thing you want to do is on this stone out here, you want to right-click over part 2. You want to select modify. Here is where we are able to modify its weight. We can modify whatever we would like. So right now we're on mass properties. Instead of geometry and material, we want it to be a user input. And we want our input to be 1 kilogram. Select apply and hit OK. Next thing you want to do is we want to go back in and set its initial velocity. So modify it again. Instead of mass properties, we're going to be doing velocity initial conditions. We want it on the X and the Y axis. On the X axis, type in 6 times cosine 6d, d. And then you need to do the units as well, which is meters per second. On the y-axis, we can just copy and paste this and switch from cosine to sine. Once that is done, you can select apply and you have your initial velocities. Select OK to get out of it. The next thing we want to do is right click on here, but instead of modify, we want to go down to measure. And in the measure name, we're just going to put R underscore as the name of our measurement. We want it to be centimeters position along the X axis. Select apply and hit OK. And now we will have this box pop up right here. You can exit out of one of them. It will pop up too. Next thing we want to do is simulate the model. Move this down. Under the simulation tab here, we want to mess with the settings. So for end time, we would like the end time to be 1.5 seconds. And not steps, but step size, we would like to be 0.02. Then we can run our simulation where the ball will go and restart it. We move these away. You can see the ball goes away and we can track its distance right here. So let's first get the orientation corrected so that we are able to see everything. All right. So we were able to change the magnification using this, holding down the left button. We can zoom in and out. So now we're able to actually see all of our simulation. So the next thing we want to do is go into the animation right here. And it'll pop up our animation controls. We can use these increments down here to track the increments and try and find where the ball hits the ground after being launched. You can slide this as well. So we're getting closer here. And right there, you can see it hits the ground. So now we want to go over here and do trace marker. We don't need to name the trace marker. We can right click, do marker, and browse. And we want to select centimeters. So now we have our tracker down here on our graph, and you can see that it shows our current distance and the time that elapsed for that. Using some basic calculations, we can verify this data. Thank you.